Good morning and welcome to our Chapter 5 Study Guide Solutions. On 1 and 2, we're asked to see if that ordered pair is a solution. So every equation has an x and y value, and if it makes a true statement, then we know it is a solution on the line. So on number 1, if x is 2 and y is 4, and in the second one, same thing, we have to see if it's true or not. So we substitute in to see, and -2 equals -2, so we know that point is on the first line. On the second line, we check it. We get 2 times 2 plus 4 equals 6, and we know that's not going to be true, so that point is not on that line. Therefore, it cannot be a shared solution for the two of them. On number 2, we substitute in again. We see that the point is on the first line because 0 does equal 0. And on the second line, we see that -7 equals -7. So yes, it is a solution for both equations. Therefore, it must be a shared solution. Number 3, we're going to solve by graphing. We use our y equals mx plus b, where m is the slope, the rise over the run, and b is the y-intercept. We learned all of this in Chapter 4, but we use it again in Chapter 5. And for the rest of the year, really. So on the first equation, we're going to graph that in red. I'm putting the y-intercept is -5. The slope is up 3 and over 1. We know it goes in a positive direction. And then the second equation starts at -3. And the slope, when there's nothing in front of the x, it means that there's a 1 there. So we can rise 1 and run 1. So we go up 1 over 1. We see that these two lines have one shared solution, which is 1, -2. On number 4, we graph these two. We start at 1. We go down 2 and over 1, but we could have also chosen to go up 2 and over a -1 and draw our line. Second equation I did in green, where the y-intercept is -2 and the slope is 1 again. And our shared solution is 1, -1. On number 5, we can solve any way we want. I chose to use substitution because it's set up for substitution. So it tells me that y equals x minus 7. So I can trust that. And in the second equation, put the x minus 7 for the value of y. And equaling 8. And then combine my like terms and isolate my variable to get x equals 5. And now we can solve for y because it says y equals x minus 7. And now that we know x is 5, we can just subtract 7 and get -2. So if we graph these two lines, it would collide at 5, -2, because this is the shared solution. Number 6, I look at this and I see, if I added these two equations up, the y value would eliminate. So I'm going to do that. I get x plus 2x equals 3x, and 14 minus 8 is 6. And I solve for x getting 2, and I can substitute in for either one. I can put in for the first equation or the second. I'm going to choose to do the first one just for fun. You could do the second one. It won't matter. You'll get the same value for y. So when x is 2 plus 3y equals 14, I subtract 2, divide by 3, and I get 4. So the one shared solution is 2, 4. On number 7, I don't have anything that eliminates naturally. So I have to change an equation so that they would. If only one of those x values was positive, I could eliminate. So I'm choosing to multiply the top equation by -1, and I have to do it to the whole equation. So -5x becomes positive 5x, and 7y becomes -7y, and 11 becomes -11. Now I can add up these two new equations, eliminating the x and solving for y. Once I know that y is -2, I can choose which equation I want to substitute in for. I chose the top equation. So I would have -5x, and then I'm putting in the -2 for y. 7 times y, which is -2, equals 11. And notice I always go back to the original equations to substitute in. And then I isolate my variable, and I get that x is going to be -5. Number 8. Lots of ways to do number 8. You have to decide whether you want to eliminate the x's or the y's. I chose the y because I only have to multiply one equation. If I chose the x, I'd have to multiply both equations. So I chose to eliminate the y, multiplying the whole second equation by -4. Keeping this first equation the same, and when I add them up, the y's eliminate, and I get -11x equals 44, and I solve for x. I'm going to substitute in for the second equation when x is -4. And then I isolate my variable, and you can see it always goes back to what we learned in chapter 1. So the one shared solution is -4, 0. On to some word problems. Maribel has $1.25 in her pocket, and this is made up of quarters and dimes, and there's a total of 8 coins. How many coins are going to be quarters and how many are going to be dimes? So the hint here is that one equation is on the total number of items, and we can see that there are 8 coins, and what is made up of that? Quarters and dimes. Anytime that's a coin question, they have to tell you the total value. So the total value that she has in her pocket is $1.25. And what is the value of a quarter? And what is the value of a dime? And now I have one equation on the total number of items and one on value. Now you eliminate. I always choose to eliminate the dimes in these cases because to multiply by 0.1 is very simple. So I multiply the first equation and getting -0.10 and quarters and -0.10 dimes equals, and 8 times -0.1 is just moving the decimal point over one space and making it negative, but you can use a calculator, so don't worry about that. And I keep the second equation the same. And the magic is I can add up these two equations, eliminating the dimes, and I solve for the quarters, getting that there's 3 quarters. I substitute back in the quantity equation, solving that I have 5 dimes. Now the great thing is I can always check these, right? If I check this and you have the entire class period for this test, I can make sure that my answer is correct. If I have 3 quarters, that's 75 cents. And if I have 5 dimes, that's 50 cents. And if I add that up, I get $1.25, which is what we know she had in her pocket. All right. These questions that are about current and a person, place, or thing that's fighting against the current or with the current are called rate problems. I set up my table, and I know that I always have the help of the current, and I have against the current, where the X is always represented by the person, the place or thing, or not place, but the person or the thing that is getting the help of the current or the hindrance of the current, and Y is always the current. So then I look at the time it takes, and the time is 2 or 3 hours. We know with the help, it's always faster, and against is always slower. So we put the slower time with against and the shorter time with the help of, and the distance is the same. Now, anytime we have something multiplied by x plus something or a family inside there, it's parentheses is multiplying. That means we have to use the distributive property. So I write my two equations, and now we're back to solving by elimination. With these problems, with current problems, we always eliminate the y value because they are the opposite already. So I want to find a common multiple with 2 and 3, and that will be 6. So I multiply the top equation by 3 and the bottom equation by 2 so that I can eliminate the y value and solve for the x. And in this case, we find out that Paula can row 2.5 miles per hour. And we substitute back in, picking any of the original equations. I always choose the top one because it's usually the smallest and the simplest. And if I substitute in x, I get 2 times x plus 2y equals 6. So 5 plus 2y equals 6. And I isolate the variable, solving for the current, which is going to be 1/2. So I know Paula rows 2.5 miles per hour, and the current is 1/2, which makes sense because if her rate is 2.5 miles per hour and she gets the help of 1/2 a mile per hour, you can see that it would, in 2 hours, she would only go 5 miles. But if she gets an extra 1/2 a mile per hour, then that would give her an extra mile, and that's why it's 6 miles in 2 hours. And the same as with against the current, it's going to take her an hour longer because it's fighting by half a mile per hour. So it's going to add a whole hour to her trip. All right, let's look at a mixture problem. Now, mixture problems are very similar to the coin problems, except we have to do one about the total amount. So we're going to see that this mixture is 8 pounds of raisins and peanuts. So that one's really easy, just like the coin problem where we have how many coins, right? But this one, when we talk about an equation about value, we know the value of peanuts and we know the value of raisins, but what we don't know is the value of this new mixture, right? So we have to do the pounds times what we are going to sell this for, times 2.20. And this is usually where people make the mistake. So really practice this, okay? So then 8 times 220 is 1760. And then I choose to solve by elimination. You could solve by substitution if you wanted. I'm going to eliminate the peanuts. So I multiply the top equation by negative 1.6 so I can add that up and eliminate the peanuts. When I do that, I end up solving for the raisins, and I get that there are 6 pounds of raisins. And when I put it back into the equation, that means I'll have 2 pounds of peanuts, right? Now I can check this equation, but how? I use the value equation to do this, because if I have 2 pounds at $1.60 and 6 pounds at $2.40, will that equal $17.60? Well, at 2 pounds at $1.60 is $3.20, and 6 pounds at $2.40 is $14.40, and that does add up to $17.60, right? They have to make sense. Algebra has to make sense. Okay, perimeter problems. I always like to sketch these out, and I look at what I have. I have 2 lengths plus 2 widths equals the perimeter, and they have to tell you the perimeter. And then what else does it tell you? It says that the length is 5 more than the width. And this is set up for substitution, so I like to solve these using substitution, but you could totally do elimination if you wanted to. It's up to you. I can distribute here, isolate my variable, and I find that W is 9. And it's very simple to find out what the length is because our first equation from the information about the length tells us that the length was just 5 more than the width. So we know it's 14. I can also check these, because if I have 2 of the lengths plus 2 of the widths, that'll be 2 14s plus 2 9s. That's 28 plus 18, and that does equal 46. So we're good. All right, number 13. Alex and Jeremy are both saving money. And Alex is saving $30, and we'll say he already has $30 and he's saving $5 per week, where Jeremy has 48 and is saving $4 per week. And how many weeks will Alex and Jeremy have the same? When will they be equal? So we write our equation for Alex. He has 30 and saving 5 a week. Don't forget your variable in here. That weeks really matters, because we're trying to solve for weeks. And Jeremy is $48 plus $4 a week. And then we just isolate our variable, and we get that the weeks is 18. So how could I check this? Well, I could substitute it in. And if Alex is saving for 18 weeks and Jeremy is saving for 18 weeks, this should be the same. And we could also find out what that value is. And we see that Alex is going to have 120, and so will Jeremy. So they will have 120 in 18 weeks. All right, tell whether the system has one solution, no solution, or infinite many. And we just solve them like we have been. That's all you have to do. 14 looks like it's set up for elimination if I multiply the top equation by 2. So 2 times 6 is 12, and 2 times negative 7 is negative 14, and 5 times 2 is 10. Second equation, I leave it and add them up. And when I do this, I see the x and the y's both eliminate, but 10 and 10 do not eliminate. 10 plus 10 is 20. So 0 cannot equal 20, so I know this is a no solution. On 15, it looks like they're set up for substitution. So I'm going to go ahead and substitute that negative 2x plus 4 in for y. And 2x minus 2x is, they eliminate, and I get 4 equals 4, which is true. So that means this must be infinite many solutions. On 16, I can solve by graphing, substitution, or elimination. It's my decision. On the test, if you solve for 1, that's all you have to do. But if you solve for more, you get 2 extra credit points for each way you solve it. So I'm going to see that Bowling Square charges $1. Bowling Square charges $1 for shoes and $2.50 per game, where Bahama Lanes charges $7 for shoes and $1 per game. When will they be the same? So I write these two equations out and I solve for when they are the same, right? I'm just going to set up my graph here. Putting the money is always the y value. So games are going to be on the bottom. And we're trying to see how many games will it be the same, right? So my slope on Bowling Squares is 2.5. So I have to change that into a fraction. So I can do my rise over my run if I'm going to solve by graphing. So my y-intercept is 1. My slope is 2/5, and I graph that line. Bahamas starts at 7, and it just has a slope of 1. And I can see that they will, the x value is games, the y value is cost. So where they collide at 4 games, the cost is $11, right? All right, so let's say I want to solve by substitution. I know that both of these equations I wrote were C equals. The cost equals for one and the cost equals for the other. So because of that, I know C equals C, so I can substitute them in for each other and say 2.5 games plus 2.5 games plus 1 equals 1G plus 7, and I solve for the the games, and I should get the same amount, and I do. I get games are 4, and when I substitute that in, I chose the second equation. If G is 4, then I have 4 plus 7 is 11. And again, I get at 4 games, it's $11. If I use elimination, I set these two equations up, and if only the C value was a negative, they would eliminate. So I multiplied the first equation by -1. And I eliminate the cost, and I solve for the games, which again is 4. And I could substitute that back in, which we already know is going to be 11. So again, it's always in 4 games, it's $11 for bowling squares and Bahama Lands. Now we have some review problems. Yes, these will be on the test, and of course, getting ready for our final. Coming up here, we want to make sure we remember how to do all these things. So I distribute first. This is just back to chapter 1, isolating my variable. I PEMDAS before I can SADMAP, so I'm subtracting now, using inverse operations, and dividing by 3, and I get x is 5. That's it. On 18, I need to convert this into slope-intercept form, which means I need to solve for y. So I subtracted 6x from both sides, and I divide by 3. And I get y equals -2x plus 4. On 19, I want to write the equation in slope-intercept that has the slope of 4 and a point of -2.5. And this was probably the most tricky situation. And on the final, you'll have to write in words how to do this. So you need to know how to use point slope form. So if I have a point and a slope, I use point slope form, right? So y minus y1 equals my slope times x minus x1. I go ahead and substitute in for my y1, which is 5, and I substitute in for my slope, which is 4, and then I substitute in for my x1, which is -2, but I'm subtracting a -2. So now I just simply solve. If I'm going to solve for y, I have to first distribute the 4. 4 times x is 4x, and 4 times a +2, because a negative is a positive, gives me 8. Now all I have to do is subtract, but use my inverse operations and add the 5 to both sides. I can't add 5 to x, you guys. Some of you did that on the last test. I can only add it the common terms, right? So y will equal 4x plus 13, right? Okay. I will have office hours tomorrow at lunch if you are a B-Day person. And of course, there's warrior time after second period. And I will be doing Zoom review tonight. If you have any questions, 7 o'clock, come on to Zoom, ask questions. If you email me before, it preps me to know what kinds of questions to really focus on. But I am here for you. You can do it. All right. Talk to you later. Bye.